Hey everybody, welcome back to the Rust beginner tutorial on coding in crypto. So today we're going to be talking about collections. We're going to talk about tuples, arrays, and vectors. And we're going to take a look at how you can iterate over those objects. So to start, let's start with the tuples. So tuples are pretty simple in Rust. You basically just use the parentheses to declare them. So we're going to say let tup. And this is how you tell it what the types are supposed to be. Put up the parenthesis. And we're just going to do two signed integers of 32 bits and a string. And we'll set that equal to 1, 2, and string from Paul. Cool. So there's a tuple. So if we just did like print line here, whoops, I'll show you how you can access those values in a tuple. So tup, and then to access the index of the tuple, you just do a dot. And you can see they come up here in Visual Studio Code. So we'll just go ahead and print each of those. And these dang semicolons. And we'll just see what that looks like. Go into the basics folder here. And run a cargo run. Oops, didn't save it. There you go. Now, what if we wanted to do a mutable tuple? Can we do that? Can we change just one value at a time? Well, yeah, sure. So let's go ahead and just make this immutable. And we're going to go ahead and just copy these down here because I'm going to print all the values again. But let's go with tup, and we'll change the string one, so in index 2, to a new string, and we'll just change it from Paul to John. So now if we take a look, there you go. So that's how you change a value in a tuple. That's how you do tuples in Rust. Super convenient. And now we're going to move on to arrays. So I'm just going to minimize this a little bit. And if we want to take a look at arrays, they are also somewhat straightforward. There's a couple of cool things you can do with arrays. Like you can use them to basically do different operations. And here's an example of a mutable one. So I32. Now when you declare an array, you want to do this bracket syntax here and declare the type that's going to be in the array. They've all got to be the same type. And then you put the semicolon, and then you tell it what the length is going to be. So we're just going to do a length of 3, and they're all going to be I32s. Awesome. Now to declare that, you could just put the values in yourself. And we're just going to do 4, 5, and 3. And I'll show you a couple ways that you can initialize an array without just like manually putting these variables in, or these values in. But either way, since this is mutable, to change a value in the array, you just reference the index like this and set it equal to your new value. So we're going to set both 0 and 1 equal to 0 and 1. Actually, I'm going to do 1 and 2, so the array comes out as 1, 2, 3. And then we're just going to do a quick loop over the array, referencing each value. And we're just going to print out each value as X. So we'll change this over to arrays, and we'll get a cargo run going. And you can see 1, 2, 3. Nice. Another way you can initialize an array is you can actually initialize with an expression. And this is pretty neat. I love this feature. So you can actually you can declare the array just like we did, right? So I32, we're going to do a length of 5 this time. But I don't really feel like typing out 5 whole values. What if I just want them all the same? What if I want them all to be zeros and I want 5 of them? Well, all you have to do is put the brackets up like you did before, type the value you want in each field, and then how many? 5. Bingo. So that'll give us an array of size 5 with all zeros. And I'm just going to copy paste this because I'm lazy. And this will give us a printout of all those zeros. See? So 5 zeros. Nice. Now, there's another cool feature with arrays. You can use them to initialize variables. So this is a little bit tricky, but follow along, and I'm sure you'll get it. So we're going to initialize an array, but we're not going to give it a name, right? Like there's no variable name here. We're going to put the variable names in an array itself. So I'm going to put two variables called Greg and Mark in this array structure. And I'm just going to put another array structure here, and we're just going to create some strings. So we'll do Greg.toString. And here's another way to create a string that we might not have covered yet. And Mark.toString. It's just going to go from a slice to an actual string object with that method. Nice. So now what this has done for us is initialize two variables using an array. And it's implicitly determined that they're going to be strings. So we can actually print each of these out, but like, how do we reference these? Like we said, we don't have a name for this array. Well, technically this array doesn't exist. It was just used here to build these variables, and now you can just access the variables as if they were normally initialized on a single line. See? And so we'll do each of that for Greg and Mark. We'll take a look at what that looks like. Boom. So kind of a neat feature with arrays. So now we're going to move on to vectors. So a vector in Rust is very similar to a list if you worked with lists before. It's just a collection of items, and they have a little bit more flexibility than arrays. Like an array is very size sensitive. In fact, whether it's immutable or not, you can't change the size without overwriting it. So with a vector, you can. You can append stuff to a vector, and it's designed to recreate its own length in the memory of the application. So pretty neat feature. And you can see in some of these examples we're going to write of that, like they'll see that flexibility compared to the array examples we just did. So to initialize a vector, this is how you declare the data type. We're going to stick with I32. And you could do it like this with the vec macro. And this is going to just let you type an array and it'll convert it into a vector. You can also do, let's make a mutable one here. You can also do same data type declaration. You can use this range syntax and then just do dot collect and make that into a vector with numbers 0 through 10 in each position. How cool is that? That is so cool. Anyways, we're going to copy this loop again. Again, I'm lazy. And I'm going to come down and print out each value in the vector here. Whoops. And so we'll be able to see what that looks like here. Now, obviously, you know it's just going to print 0 through 10, but we're going to see what that looks like. And now while we move on, I'll give you an example of appending to a vector. You just do vector.push -2. Now, one thing to note is we made this thing mutable. So if you don't make it mutable, you're not going to be able to push new values to it. That's just straight immutability, obviously. But as long as it's mutable, you can change values, you can change the length of it, you know, you could do all kinds of things on there. And since we're pushing there, I'm going to print out the last value of the vector to see what we just pushed on there, right? So our last value right now is -1, and then we push -2 on there. So if we print this syntax here, we do vector and then we reference the index. Now, if we know this thing for sure is going to be 11, we could put 11 here. But the proper way to find the last index of a vector is to just do the length, vector.len -1. And that should give us a nice printout of the last value. So I'm going to just comment this out while I run this so you don't get confused. But there you go, is the -2. I always forget to save it. Either way, we got that -2 out there, so we know that that's our last value. So what we're going to do now is we're going to demonstrate a pop as well. So we're going to do same print, and we're going to do vector.pop. And what pop does is actually removes the value from the vector. It'll pluck it out or pop it out and return it. Now, right now, Rust is yelling at us because the pop function actually returns an option. So what an option means, and we're going to talk about this in a couple videos from now, it basically means that you can either get a value back or you can get none. And in order to handle that operation, you're supposed to write like the handling, basically how you want to handle the two possible outcomes of an option. But for simplicity here, since we're not going to dive into that just yet, this is a print filter you can add that will automatically recognize that this is going to return an option. So all you got to think of right now is this pop function could return a value, but if our vector is empty, like if you do this on a loop and pop all of them out, you're going to get none. So I'll demonstrate what that looks like, and then I'll even show you. See, like sum -2. Sum is the option return of a valid value. So if we go like this and we say loop, actually that's probably not a good idea. I won't do a never-ending loop. I'll do a for x in 0 to 20 so you can see some of the none printouts. So this is going to pop every single value, and as we get past 11, since we're only going to have 11 values or 10, this is going to pop us up into the none return values, and you'll see that. See? We get some value each time, and then once our vector is empty, we get none. Cool. Nice. So we're going to move on now to, and I'm just going to set this back to this so that nobody gets confused if you're looking at the code on GitHub. We're going to move on to iterating. So iterating is pretty neat. Like you just saw the for loop is one way to iterate. That's a pretty traditional way to do it. But there's more robust ways to iterate over these different data types in Rust. So let's take a look at iterating over arrays. So we'll start with just a typical array. We'll just say we'll go with I32 again, 5, and we'll do this all zeros because it's cool. Now, the first way we can iterate over something in Rust is using the built-in function for arrays called .iter. So if we do for x in r.iter, and we just want to print x, we could do that. Now, a couple important things. So obviously, at a basic level, x is going to iterate over the array, and we're going to get each value of the array. But what's important to note is .iter is actually built in referencing the array. So this is going to be by reference, and I'm just going to do .iter in parentheses. Now take a look. If I try to actually reference the array, it's going to geek out because this is already referencing it. So you don't need to put the and sign in front of that. Sweet. Okay. So now let's take a look at what's called enumeration. So we're going to do the same thing, but we're going to enumerate this. Now already you can see that this is now throwing an error, and that's because enumerate, and let's see what Rust is saying. See, it's giving us this tuple here. That's saying that's what x represents. So enumerate is going to actually give you the tuple representation, gives you a tuple, and it's going to look like this. It's going to be the index of the array and then the value. So super important to know, this is extremely convenient because use cases for this come up all the time where you need the index and the value. This is how you do it. And again, since we're using .iter, we're still going to be referencing that value. So again, like we saw in the tuples above, all we got to do to get the value is just reference that tuple index. Sweet. And so now we'll just give this a print and just take a look at what that looks like. So there's our zeros, and obviously we're just printing the values here. But if we wanted to do like x.0, we wanted to comment this out, you can see there's the indexes. So pretty neat. Now, these two examples that we just went over are by reference. So is there a built-in iteration method for taking the value itself and not just borrowing? Absolutely. So we're going to do by value. and it's actually called into iter. So kind of confusing. It's very, very similar, you know, dot iter versus dot into iter. But if you can just remember that the dot iter is going to be referencing it. And then if you go into iter, you're pulling the value in. So you're not borrowing. So one way to kind of think about it. So we'll do for x in R. And actually, I'm going to make this item because we're going to mess with that enumeration a little bit. And we're going to say into iter. Enumerate. And then, as you saw, it's going to be a tuple. Now, you can choose to do both index and value of the tuple. So that looks like this. You could say let I and x, and this time we're using a tuple instead of an array to create these values. Same concept though, still pretty cool, because we want to have two different types. So that's why we would use a tuple here instead of like we saw up here, where we're using an array to create two values. That's because these we know are going to be the same. They're both going to be strings. But down here, when we use a tuple, we can tell Rust, like, hey, one of these, the first one is going to be a usize, and the next one's going to be an I32. So we're going to set that equal to item. And really quickly, usize is a representation of length. It's a representation of index. Like, it's used to determine a number that actually represents stuff that's coordinated on the stack and the heap. So if you watched the borrowing video earlier in the playlist, you kind of understand what this is pointing to. I did reference it in that video as well. So now that we've done that, we can just print out, let's just do like, we'll say index, oops, and we'll say, we'll make those brackets there, and then we'll do value brackets, and we'll just do I and x. Now, we could have totally done this like we did earlier, but it's a little more clean to do this. And obviously, in the typical use case, you'd be doing more than just printing these things out, so it's good to toss them in their own variable for the scope of the for loop. So totally cool. Let's take a look at how that works. Right on. Sweet. So that's arrays, and iterating over vectors is actually very similar. So they iterate the same as arrays. And there's a couple like cool features about vectors that we'll cover too, but just to show you, we're just going to let the vector equal I32. And since I love this range collect guy, we're going to do that. And now for x in vector.iter, we're just going to print line x. So you can see it's exactly the same as the array one. Literally the same. Sweet. And all of these are the same too. And it returns the same tuple. It works the same exact way. So what's different about vectors then? And I'm just going to do a quick print line here. And just we're going to separate the vectors from the arrays. So what's neat about vectors is you can also do stuff to a mutable vector. Like we covered earlier how you do different things like pushing and popping to a mutable vector. But when you iterate over a mutable vector, you can actually do stuff to it while you're iterating. And that looks like this. We're going to create a mutable vector called mute vector. Use I32 again. And you know I'm going to use this range function again. And now that we've got that declared, we're going to do for x in mute vector dot iter mute. So iter mute actually is going to iterate over a mutable vector and allow you to do things to the vector. So this is what that looks like. Asterisk x, and we're just going to add 3 to each value. Now, what this asterisk is actually doing is called dereferencing. So if you watched the video on borrowing earlier in this playlist, you know exactly what that means. But in a nutshell, this asterisk tells Rust, like, okay, even though x is just like serving as a representation of this value, since we're iterating with this mutability feature, we're going to dereference from x to the actual value in the vector. Like, actually do this function on that thing inside that vector that we're iterating over. So that's all that means. Now we can print this out, and you're going to see the same like syntax we saw earlier when we printed a whole vector, or we printed like a vector pop. We're going to use the same option filter here with that question mark, because when you print a mutable vector, Rust doesn't really know what size it's going to be. Like, it can't predict it ahead of time. So it could be 0. It could have nothing in it, and you're not going to be able to print anything. So this also returns an option like we covered earlier, and I promise that will become clear in the later video. But for now, let's just print this out and let's see what we get. Sweet. So you can see that we printed out our original vector, 0 through 4, and now each of the values in here are actually increased by 3 because we went and added them there. So pretty neat. Iter_mute is a pretty powerful function. Allows you to just kind of simplify things by dereferencing. Super, super cool. In the next video, we're going to talk about options and matching. So you're going to see a little bit more fleshed out details on some of the things we glossed over in this video. So that'll be super helpful. Thank you for watching and stay tuned.